Hi everyone, so in this video we're gonna talk about the law of conservation of mass. So law of conservation of mass states that mass can neither be created nor destroyed, and its atoms in the reactants rearranged to form new compounds. I will be demonstrating the law of conservation of mass using two common household materials, the baking soda and the vinegar. Now, the sodium bicarbonate or the baking soda will be the limiting reactant, while the acetic acid or the vinegar will be the reactant in excess. Now, flash on the screen is the balance equation of the reaction of sodium bicarbonate and the acetic acid. So it yields the product of sodium acetate, carbon dioxide, and water or the H2O. Now to start our demonstration, the mass of our open system, which is the beaker and the test tube, is 229.25 grams. Now let us simply place the test tube inside the beaker. Now placing the acetic acid into the beaker will increase its mass into 253.84 grams. Now to determine the acetic acid in the reaction, we have to minus the mass of the system to the total mass. And now it has a result of 24.59 grams. Now let us place the sodium bicarbonate into the beaker. Now placing the sodium bicarbonate into the beaker will increase the mass of the system to 254.83 grams. Now to determine the mass of the sodium bicarbonate in the reaction, we have to minus the mass of the system with acetic acid to the total mass of the system with sodium bicarbonate and acetic acid. We have 0.99 grams of sodium bicarbonate in the reaction. Carbon dioxide gas bubbles are out to the open system and is released to the surroundings. So the mass is lost from the beaker but conserved by being released to the surroundings. Here's the result of the reaction. The mass of carbon dioxide produced can be calculated because it is lost from the system to the surroundings. The mass goes down as the reaction proceeds. After a few minutes, we can finally be able to determine the final mass of carbon dioxide release. So the mass of the system with the products after CO2 is released is 254.36 grams. Now to determine the mass of CO2 release alone, we have to subtract the mass of the system after CO2 is released, the total mass of the system with sodium bicarbonate and acetic acid, which is 254.84 grams minus 254.36 grams. We have a total mass of CO2 release of 0.48 grams. For the theoretical mass of carbon dioxide that should be produced by this reaction, we first have to get the molar mass of the sodium bicarbonate or the NaHCO3, which is 84.006 grams per mole, and the molar mass of carbon dioxide, which is 44.009 grams per mole. After getting the molar mass of sodium bicarbonate, we have to convert it into moles of the sodium bicarbonate that reacted in our demonstration of law of conversion, which is 0.99 grams. So when we convert it into moles, it would be 0.012 moles of sodium bicarbonate. After getting the moles of sodium bicarbonate that reacted, we are now to get the mass of carbon dioxide that should be produced in this reaction. So therefore, we have to convert the moles of sodium bicarbonate to moles of CO2 or carbon dioxide. The next step is that we have to convert the moles of carbon dioxide to grams. With that, we are able to get the theoretical mass of carbon dioxide that should be produced in this reaction, which is 0.53 grams of carbon dioxide. That is it for this video. Thank you for watching, and I hope you learned something about the law of conversion of mass.